Okay, here comes problem 2. Colin and Diane, they're taking a multiple choice test in part A here. In part A, Colin is going to try to take the test, multiple choice test, 10 problems, 5 possible answers in each case. He's going to go without a net, he's just going to guess every answer. And in order to pass, you have to get 50%. Of course, that means 50% or more, right? So this is a binomial problem. This is a binomial experiment. You make an attempt at one of the problems. There's only success and failure. You get it right or you get it wrong. There are 10 problems. So in this case, there's going to be 10 trials. For him, the probability is going to be 0.2, 1 chance out of 5. You know? And then what are we looking for? Well, in order to pass, the probability of passing is equal to P of, what do I want to say, 5 plus P of 6. Maybe he gets 50%, maybe he gets 60%, maybe he gets 70, maybe he gets 80. I'm not a room, maybe he gets 90. Heck, maybe he gets all of them right. Okay, any of those pass. Any of those pass. So how the heck do we calculate that? We could go in and I could calculate using binomial PDF, P of 5, if n equals 10 and P equals 0.2, P of 6, P of 7, P of 8, P of 9, P of 10. I could add those all up, we're done. Or we could recognize that 1 is equal to P0 plus P1 plus P2 plus ... plus P10. Right? You might remember that the sum of the probabilities of everybody in a sample space, all the elements in a sample space, is equal to 1. Something, that's what I like to say, something has to happen. Right? Either you fail, or you get 1 right, or you get 2 right, or you get ... you get 10 right. With certainty, something's going to happen, okay? So we know that, and then we also know that binomial, wish I hadn't written it like that, CDF of 10, 0.2, and 4, well, that's P0 plus P1 plus P2 plus P3 plus P4. So if I subtract these two, 1 minus binom CDF of 10, 0.2, 4, well, this P0 cancels this one, this P1 cancels this one, this P2 cancels this one, this P3, this one, this P4, and you're left with this. You're left with P pass. P pass for column. Okay? So let's just see what the calculator tells us here. Turning it on, I am going to second distal. I am finding myself binomial CDF. I'm going to enter in n is equal to 10. I'm going to enter in p is equal to 0.2. The x value in this case is 4. I'm going to paste it as it says. I'm going to run it real quick. And what I get is binomial PDF is a point, let me just get this explicitly, is 0.9672. And if I subtract that from 1, I get 0.0327. In other words, not a snowball's chance in hell for a Colin to pass. Keep that in mind next time you decide to guess on a multiple choice test. Okay, I've kind of used up all the board. The problem for Diane said she's going to try 10. She's going to do the same thing here, but she's going to have a probability of 0.75 because Diane, nobody likes Diane because she studies, right? So in this case, P pass Diane this is P pass colon right here, is going to be equal to 1 minus binomial CDF. We're doing just exactly the same problem here, 10.75, what did I do, 4, because that leaves P5, P6, P7, P8, P9. So let's do this real quick. I'm back to distribution, I'm back to find, oh, that's not distribution. I'm back to distribute, I'm having a little trouble. There, I found it. Here is binomial CDF. For Diane, we're going to go 10, we're already 10, we're going to go 0.75, and we're going to go 4, and we're going to paste that, and we're going to get a very small number, which we're then going to subtract from 1, and we're going to get 0.980. Pretty good chance Diane's going to pass, having studied. Okay, hope you got that. We're going to move on now to the next problem. Let's finish off this binomial probabilities categories here. We've got 5 or 6 problems. Problem 3 is a manufacturing scenario where you've got a lot of 50 products. The defect-free probability of success, if you want to call it that, is 0.99. And you're asked, what's the probability that you have no defects in that lot of 50? At least 1 and at least 2. Okay, so you're going to find, I mean, this is true of probability. Probability often turns into kind of a brain teaser, brain twister exercise. That seems, for whatever reason, to be particularly true of binomial type problems. And you're going to see that here, and you're going to certainly see it in the next couple of problems that come up. So again, this first question is, what is the probability of no defects in 50? Well, I'm dealing right now with the probability of being defect-free. So that means that Q is the probability of failure, and that's 0.1. So, gosh, I wish I had my calculator. I do. So all I'm being asked to calculate here is the probability of exactly 0 defects, okay? So since I'm looking for exactly some number, I'm going to be dealing with the PDF. It's always NPX, NPX 50, but the probability in this case that I'm interested in is the defect probability, 0.01. And I'm interested in a lot of 50 with this defect probability. What's the probability that I see 0? So, always like to do these in real time, just so that you can see that there's really nothing to it. I just found binomial PDF. I'm entering 50 as N. I'm entering 0.01 as P, and then 0. And I come up with 0.605. Okay, that's the first answer. Second question is, what's the probability, I check 50 of these, what's the probability that I get at least 1 defect? So let's think about that. What's at least 1 mean? Well, if I check 50 and I find 1, that's at least 1. If I check 50 and I find 2, that's at least 1. Check 50, find 3, that's at least 1. So P of at least 1 is P1 plus ... plus P50, okay? So I don't want to calculate all of those using binomial PDF. Instead, I would use binomial CDF. But hold on a minute. Every time we see at least 1 in a probability problem, we're trained to go think about what the heck is the complement. Because if I can find the complement easier than I can find at least 1 defect, then I'm just going to subtract the probability of the complement from 1 and have at it. So what is the complement to at least 1? It's none. All right. So this probability is 1 minus P0 There's P0, so this is 0.395. There, tried to screw that up. So on to problem C, part C. Part C says find the probability of at least 2. Well, the probability of at least 2 is P2 plus dot dot P50 again. So let's always think in terms of complements. In this case, the complement of at least 2 is 0 or 1. P of 0 plus P of 1. Now let's use the binomial PDF or CDF, and let's calculate binomial CDF out of a lot of 50 with a defect probability of 0.01. What's the cumulative probability up to 1? That is, what's P0? This is P0 defects plus P1 defect. If I subtract that total sum probability from 1, that's at least 2. So off we go to distribution. Go find binomial CDF. I've got 50 trials. I've got 0.01. I've got an x value of 1. Okay, and I'm pasting all of that in. I get the answer 0.91. I subtract that from 1, and I get, did that wrong. I think I get 0.089 if I'm not mistaken. 0.91. Yeah, I think that's right. Okay, that's problem 3 of the brain twister group from 3 to 6. So let's go on to 4.